This is the UK Synchrotron. It's called Diamond Light Source, and it's basically a huge ring. I mean, you can see the size of the building here. It's massive. It's a huge ring that we fire electrons around really, really, really fast. Those electrons then pass through these special magnets, and you get beams of X-rays firing off. And that's what we use to do some really cool science. Let's go inside and learn a bit more about it. We are now inside Diamond Light Source, so you get a bit more of an impression now of the size of this building. So curving away there, it's a bit like a donut-shaped building. Okay, so the inside, there's actually some grass on the inside. And then round the middle is where the synchrotron is. That's where the electrons are spinning around really fast. And each of these sort of rooms that you can see radiating off from the center, those are the beam lines themselves. So the X-rays are hurtling down through here, and the scientists, we work down inside these buildings, you know, these rooms down here. That's where we do the science, where we fire those X-rays at our samples. Let's go down and learn a bit about why would you want to fire X-rays at a sample. This is the I-22 beam line. So there's loads of different beam lines at Diamond. I-22 specializes in something called small angle X-ray scattering. Okay, so we're firing the X-rays, they're coming out through a tube that comes through this hole in the wall. Okay, they're coming out of this sort of nose here, and then this bit here, all the sort of section that you'll see around here is all part of the detector. So that's where we're picking up the X-rays. And what we do is we put our sample inside there. So our X-ray beam comes and hits our sample. The X-rays scatter off in lots of different directions. And that can tell us a lot about what is inside our sample. This beam line is used to study a whole load of different areas of science. So you might get people coming here to study, say, how bones form or how problems might form in the eye, so lots of biological applications. One of the things that I'm using it for is to study how to make materials for batteries. So in our research, we're looking at a component of rechargeable batteries, so the batteries that you might have in your phone or your laptop. They contain something called graphite, which is carbon that's really layered. And they work in batteries because the lithium ions that are in the batteries can go and sit in between the layers of the graphite. It's great science, but the trouble with graphite is that there isn't that much of it in the world. Okay, so we need to find ways of making graphite more renewable. What we're doing is trying to make that graphite from biomass, so things like trees that can be regrown. And what we're doing here on the beam line is trying to learn about how that graphite forms and what might be different about the graphite that we make from biomass compared to the graphite that we can mine. And ultimately work out, you know, can we make a battery that works just as well as our existing ones, that make it from trees that we can regrow. On some of the beam lines, the distance that the X-rays have to travel is really, really far. So this here is actually a beam of X-rays above my head. And if you look down there, the tunnel you can see coming all the way out from the central synchrotron.
My name's Francis. I'm a second year PhD student. Sometimes I bring my samples here or I help out with other people's samples. We take the data and then we analyze it somewhere else, and it's a really exciting time. Obviously it's a very professional environment, but there's lots of people around here that work here consistently all year round or that come here as part of their projects. People put in proposals, and when we come here we run experiments over several days, so we have to take shifts with colleagues and academics here. Some people take the day shift, some people take the night shift, and that results in lots of data collected over several days.
I hope you've enjoyed this brief tour of the Diamond Synchrotron facility. Please check out the other videos on our YouTube channel.